Thank you. Yeah, in case you haven't noticed, we sort of changed the title from and the abstract. That is because we held this talk before, like a couple of months ago, when Flow was still more of a thing. And now a lot of that has changed. We're going to talk about that some more. So now we're going to focus on TypeScript and especially the type system, and focus on the more complex part of TypeScript and the new features. So something about David?
Yes, so my name is David. It's already been mentioned before. I work for TNG. I've been working for TNG for a year now. I used to be a physicist, actually. So I'm sort of a scientist turned web developer now. Yeah, currently doing lots of PHP, JavaScript at work. Yes, and also I've been using TypeScript for a while in smaller projects, mostly my own stuff.
Yeah, and I'm a typical software developer. Started with BASIC when I was like 12, then did some JavaScript, and then went for compiled languages for I think the next couple of years. And now I'm doing more dynamic languages. But so we come from different backgrounds, and that sort of influenced this talk. So yeah, let's get started. There are pretty much two things we want to talk about. First, we believe that types are awesome, and types have a bad rep in the JavaScript community for no valid reason, we believe. I think every style of JavaScript allows for types, and that's one of the things that we're going to talk about.
Maybe before we make such bold claims, I'm just interested out of curiosity. So who in here uses TypeScript, actually? On a regular basis? Yes. A couple of TypeScript users. Anyone using Flow? Yes, it's still a thing, Flow, yes. So, hey. All right. Okay, so yeah, it's... So.
Yeah, and by the way, if you have any questions, like this is a meetup, just if you have any opinions, questions, just ask them when you have them. Okay, next up, the other thing we're going to talk about is the new features of TypeScript, because I think by now everyone has heard at least one talk about TypeScript, so we're trying to not repeat ourselves too much, and focus on some of the new cool features, especially the ones related to the typing system. Okay. We didn't agree like who's doing which slide, so this might get awkward at some point, but that was completely intentional.
Get awkward. Yes, so why do we love JavaScript? It's so much fun, right? Everyone knows it's so much fun, that's why we're all here. Fun side of JavaScript. It's super easy to learn. I just overheard a conversation earlier, someone saying, oh yeah, like I'm doing a Node lecture at some university and people like, everyone knows JavaScript these days or something. Yeah. All right, was that you? Yeah. All right. So that's what it is. Millions of libraries. Sorry? I think that's probably. Yeah. Well, just wait till you see the next slide. Yeah, there's so many libraries, like the ecosystem's growing very fast. That's what I like a lot. It runs on, sorry?
Is it left path?
That's in the next slide, then, yeah.
It runs on anything, so it used to be, of course, written for the browser. People used to do JavaScript in the browser. Nowadays, there's, of course, Node, and you can use it on all kinds of devices. You have functions as first-class citizens, so actually JavaScript, like some of you might know, it's okay as actually a pretty nice functional language. You can also write code in a functional style. Well, loose typing, some people really love it, like they say they're more productive and flexible with such a system. It's prototype-based, so it's object-oriented, but...
more powerful even than object-oriented.
Yeah, but yeah, not class-based, but prototype-based. Their object literals are a really popular format. Everyone knows it nowadays, and used for pretty much all kinds of REST APIs nowadays, and well, sort of a native format for JavaScript. And many other things. So, yeah.
And that was the part that you mentioned. Ah, no, actually, something else.
This thing. I actually brought something here. So it's actually so easy to learn that you can order this book from Amazon, and this is what I did. It's called JavaScript for Babies. It's really lots of fun. So you can really... I use this to learn JavaScript myself. Anyone here have kids that would be interested in this? I'm happy to give it away. It's just well, €7. So.
And the thing is, if you read the comments on there, you're not actually quite sure if this is a joke. Like people asking for like, yeah, it would be nice if it were made out of cloth because my kid will destroy this. Like, are you serious? It's like.
It's quite fun. So even if you don't want to buy this, you should still go on Amazon and look at the comments.
Well, it says Web Design for Babies Volume 3.
So yeah, let's assume this is a joke because I can. Let's just hope. Okay, but the ugly side of JavaScript, you've already mentioned that. Part of our problem is that the language is so easy to learn. And that there are millions of libraries. Like you said, there's LeftPad, and we start to... like reusability is nice, but sometimes we're overdoing this. Sometimes we're also not thinking in the long term, and projects get thousands of stars on GitHub, and then after a few months die out. And then you have to rewrite the code that used it and make all the changes. So that is unfortunately the ugly side of JavaScript. Then of course you all seen the talks about the crazy things you can do with semicolon insertion, the comparison table. Axel posted a new one on Twitter the other day where it's like even a strict comparison, like two empty objects strict compared with brackets around it, and it's false. And just new crazy stuff coming up all the time. But the major reason for this talk and the thing that bothered us the most is that bugs show up at runtime. I mean, I love dynamic typing because it's flexible, but the one thing that bothers me is that I would like my weekends to be weekends and not being called in the middle of the night because something didn't work and something that was not in the tests turned up only at runtime. So if possible, we would like to overcome this. And the reason for this, I write a lot of static analysis tools, and static analysis on dynamic languages is incredibly hard. I spent half a year on my thesis trying to do this for JavaScript and PHP, and it's difficult guessing what the language is trying to do just by looking at the file without executing it. And also lacking IDE and tool support if you come from a language such as Java and C#, which has its downsides, but the IDE support is great. And by tool support, of course, we have amazing tools in JavaScript. But what I mean by that is like we don't have good tools when it comes to like architectural validation. That's sort of something where we're still lacking in JavaScript. And of course, there's more for this one as well. Yeah, but because Christmas is coming up, we can write a wish list. Like, what would we actually want for our language? So I'm sure we don't want something like Java. Like, I think we are all here because we're somehow not happy with the way that some of the compiled languages force us to work. So, for instance, something that you often see in Java is like you declare a list of customers, and then you first have to specify the interface, and then you specify the type that goes into that collection. And again, you repeat the same information in the back, and you say what implementation of the interface you actually want to use. And there's just so much redundancy in there. To be fair, like you don't have to do it that way. You can use an empty diamond operator now, but still that's just a very verbose and the reason why a lot of people are fed up with Java. So what we would actually sort of want is to just say that this is what type of list that we want, and maybe even what type it is. Or if we go one step further, we could just say, okay, we want some list, and then maybe we'll even have a compiler that is smart enough to figure out what type of list we want by the things that we put into the list, or the set, or the map, or whatever we have. Yeah, so that is something that would be nice, just having types, but we don't want the types in a verbose way.
What else do we want? What else is on our wish list? Simple integration. So we want something that's sort of easy to switch to, something that is easy to add to an existing project, for example. Lots of us work on sort of legacy code. You can't just like commit or directly commit to having types everywhere. We also want something that's easy to remove. Maybe we don't want to go all the way yet and be we don't want something that's either that forces us to like go all the way or leave it. So we want something that we can also easily migrate away again if we want to. We want support for object-oriented programming. I mean, prototype-based programming is nice. Well, it's object-oriented as well. We're sort of used to doing writing reusable objects, reusable classes, something like this. We want maybe support for functional programming. So we're JavaScript developers, so we think it's cool to have both options. We want, that's sort of same idea. We want to have an easy migration path. We want to have clear steps that we can take without going all the way at the same time, step-by-step migration. And instead of, why is this crossed out again?
Yeah, I just felt like make it sound easier, but that was probably not a good idea. Yeah, because I think in the end, a lazy developer doesn't have to be a bad developer. If we're intelligent and lazy at the same time, I think that's a good thing. We just have to be the right kind of lazy. So I believe that everything that makes me write less tests and with the same amount of coverage or even more coverage, that's a good thing for me. If a tool saves me the work of writing tests, then I'm very happy to have this. On another JavaScript meetup, I had this conversation the other day where with a person who was not a big fan of TypeScript, and he said yeah, I enjoy writing tests so much that I don't need it. And yeah, but I'm saying yeah, I do test-driven development, but it's not it's the main reason why I write code. So that's nice to have if we can get it.
And what a lot of people end up doing, they even end up having to write code to make their JavaScript safer that actually has a runtime performance impact. So JavaScript is evaluated on every run. So whatever, TypeScript, the additional stuff that the TypeScript compiler is doing for us is done once. It's the transpilation step that happens once. So whatever saves us from writing JavaScript makes us actually faster, makes the program faster. So something like this. I mean, this is sort of the classic. You want to just add two numbers, and then you just, you start writing a function like function add and return a plus b, but then you're like, oh, but what if someone puts in something that's not an integer, or puts in a string in an integer, and then I don't really know how this behaves, and I could read this table thing, but I want to be sure, so I write this check, and it just, it's not really nice, I guess, and it makes it actually slower. So this is what we want. We want to just say, I want to add two numbers, and they better be numbers.
Yeah, I think we have the running example here. On the top here is, again, okay, let's just use that one. Left side is TypeScript. In case you haven't seen the playground, you can just try TypeScript on the left side, and then it compiles it to JavaScript on the right side. It's quite nice to try out different features. I would recommend you to turn on Safe Search if you're Googling TS Playground. Yeah, because I found that out yesterday. There's a lot of meanings for that abbreviation. But yeah, anyways, so the first function you see is I agree that's a sort of contrived example. Maybe you wouldn't even write your code this way. But as you can see, it just ends up being compiled to exactly this because that's plain JavaScript. There's nothing special about this. In this case, however, TypeScript does all the work for us, and we even see here, okay, this is like this. We see that we get a nice warning, and that happens while we type, and so it's much harder for us to actually put this into production, and we don't have to write any code for it, and after we compile it, it's all gone. And it's faster. If you were here during the V8 talk of Bernard some months ago, someone asked him this question, and at first he wasn't sure because it compiles to TypeScript, but then he said yeah, exactly this example. If there are some checks that otherwise you'd have to write in the code, if TypeScript can do this for you and then throw it away, that's less code to parse, and code that is not there doesn't have to be parsed, which makes it automatically faster. So even these little things add up. Okay, coming to the main part, type theory. We're not going to do math. We're not going to talk about that part. But I think even if you in the end decide to not use TypeScript, it's good to know more about types. And that is what that comic is trying to make fun of. That oftentimes when we have this discussion about types versus not untyped languages, JavaScript versus Java, then usually it's because we don't know the other side. So that's what we're trying to clear here.
Yeah, everyone knows this commercial. TypeScript is so famous, it even showed up in this famous TV commercial with the TypeScript guy and the Flow guy, the hip new guy on the block, Flow. Yeah, that was funny in our other talk. It's not so.
Yeah, we pretended to be. Yeah, but that was too awkward. So, but I agreed to leave the slide in, but I'm not going to do the role playing anymore.
Because TypeScript, that's sort of a solid guy, like sort of been around for a bit longer, and then there's like, well, also he's even called TypeScript, and then this guy's like Flow. No, we'll just skip over it. Yeah, this is even, well, let's also skip over this fast because it's like everyone cares about GitHub stars, but like everyone secretly looks at them, right? Even like that's clearly not a measure of popularity or something, but still we like to look at them. So TypeScript has more. Yeah.
Yeah, this state of JavaScript has been out for 2017, but the results, at least a couple of days ago, were not published yet. And unfortunately, last year they didn't really input Flow, but in case you need some more arguments to use TypeScript, a lot of people, and this number is growing, have used it before and would use it again. We sent out an email in our company and asked around who's using TypeScript, and we got a lot of positive answers from people who started converting recently, both in the front end and the back end, and all of them were super happy. Admittedly, a lot of them had a Java background, but still, like none of them said that this turned out badly and they wouldn't use it anymore. Okay, so yeah, and we even got Google Trends to make the point that we wanted to carry across. It took some hacking because it turns out Flow, like Rust, is a terrible name for your language because it's terribly difficult to search for solutions. But yeah.
Yeah, so
we're going to come back to Flow every now and then, but mostly we're going to focus on TypeScript.
Yes. Well, one of the things that people used to say about Flow is that it's much less invasive and much easier to migrate to. So we're now going to focus on some of the points that sort of TypeScript, in our opinion, did to remedy that. So some features of TypeScript that make migrating to it easier. Like remember we said earlier that we would like to have something that doesn't force us to go all the way right from the beginning, but we can sort of slowly migrate to. TypeInference is, of course, a nice feature. So it basically means you can start using TypeScript without changing anything. This is like the example, a similar example to before. This is what a lot of people, of course, don't want because there's so much redundancy. We have to write const customer equals new customer. That's a bit stupid. We want is something, we just want to say, we want to assign a variable and then let the transpiler figure out something for us. As in this example where I just say, well, we just declare variable x to be a string, and then we want the compiler to figure out, like, have the compiler figure out for us that that it is a string. So, what do you think? Do you think that, I mean, this is clearly an error, right? So you're trying to divide the string by 3. Do you think that TypeScript would catch this?
Sure.
Yeah. Yeah, we thought that so too, actually. So it's quite sad that like already our first example doesn't work.
Yeah, so like that's one thing that Flow does better. Flow still uses, like the name suggests, flow analysis. So they see how the variable flows through your application, and they can fix this. Whereas TypeScript is more lenient here.
Yes. So actually, how this works is, and how it's quite clear that why there's a difference here is, so the way TypeInference works in TypeScript is basically, yeah, it means guessing a type without declaring it, TypeScript without types. Isn't there this part where we explain how this works in TypeScript?
I think that's the next slide.
Okay, baby steps for now. TypeScript tries to assign a type to a variable at its definition, so this is the example earlier. So if you declare a variable x and you define it at the same time, you assign it a string, and then that's a string. What it doesn't do, it doesn't track necessarily how the values flow through your program. It does some control flow analysis, which we'll come back to later. But in this example of the function, this parameter x will just get a type any, because it doesn't really know what this x should be, the argument of the function f. So any is just what you'd expect. It's just like can be any type. So that's why it doesn't see that there's an error, because it just says, oh yeah, you're putting a string in there. Well, it's of type any, so it should be fine, even though it isn't. But what we can do is there's a couple of flags that we can use to configure the compiler a transpiler. One of them is the no implicit any flag, which then would make TypeScript complain in such a case where the type inference has just figured out that this is of type any, so it doesn't know what type it is. And you already saw that this might be dangerous, so in this case the compiler would complain about it, so it makes it a bit safer actually. Yeah, it's an example. So if this wouldn't work in TypeScript, it would work in Flow though, so because it works differently in Flow. So here you just assign an integer to this variable x, so now it's of type number, so you cannot change the type anymore because it already has been assigned a type. Yeah, so it actually complains about it.
But the good thing is with TypeScript, you can always do it step by step. Like you just run TypeScript against your whole code base, and mostly it's going to work fine. And then if you are happy with the results, and if you end up finding bugs that way, you can harden it. And if you don't like that, you don't have to do that. This is another pretty neat example where you see. So this here at the very top is specifying that this something we can pass here is either a string or null. We use this as an example, but oftentimes we know that something can be null or undefined. But in this short example, I just said that, okay, anything that can come in here can either be a string or null. So what TypeScript does for us in that case is if we just call a method on the string, then this could just be a problem, because if it's null, then that doesn't work. So TypeScript figures this out for us and warns us while we're writing the code, or stops us from compiling. However, what we can also do is when we add the check, TypeScript notice that you're actually checking for this case and removes the warning. So that's quite neat, and it just is a good example for how it does some of the thinking for you. Because sometimes you just forget that something can be undefined, or you do a lot of chaining and you forget that something in the middle of the chain can be undefined or null, and TypeScript just does this sort of searching for you. Yeah.
I have a question to the slide before that one.
Focus.
Yeah, this one. So the error is at the line where the string is assigned to x.
Yeah.
Yes.
Okay. I'm confused because I think the error would be when you use the x as a number, because it is a string. So
let's just put it in.
So is that the difference between TypeScript and Flow?
Yes, exactly.
Okay.
So what Flow does, it really tracks what type your variable has and how this sort of changes through the flow of your program. And then you can sort of figure out, at this point, this should be an integer. But this is not what TypeScript does.
Okay.
So TypeScript just assigns a type at the definition, and then it's fixed. Yeah.
Okay, let's grab focus
so you
again.
see that the error is there. All right, yeah, this was an example already of sort of control flow analysis, which Flow, of course, does a lot more of, but the TypeScript is sort of slowly catching up with these examples. This is an example which I like a lot, which I've tried, but unfortunately TypeScript is still not there, but there is some remedy. So let me just quickly explain it. So let's say I have this function where I have to do something.
Can you increase the font size?
Yes.
That might be hard on this slide. Let's see if it likes the iframe.
Yes, it works.
Sort of.
Somehow, yeah, better.
Okay.
We don't need these strings here, they can be cut off. So let's say we have a function, rate color, which does something depending on the parameter it gets. So I know this is like sort of bad style if you have like this switch statement, but let's just assume that we have this. So now we want to make sure that we have like really taken care of all the cases, red, green, and blue. So what we can do is we can put as a type annotation this, what's called a union type of string literal types. So this means color can either be red, green, or blue, and if you put in something else, TypeScript will complain about it. Now what I want to do, like what I want TypeInference to be able to do is to be able to figure out that, for example, in this for loop, I let color iterate over these colors, that I'm actually only putting in these strings, right? I mean, everyone can see that, and actually, so this is still like Flow actually gets this right, so it figures out that only these 3 colors can be in there. But now TypeScript incorrectly makes an inference of color as a string, and then it complains that string is not compatible with this union type, right? Because it could be something else, and doesn't know this. One thing you can do, though, in the newer versions of TypeScript, something that's recently happened is, so always TypeScript has had enums for a while. So of course, this is an example where in other languages maybe you would use an enum. So we define a type which can be red, green, or blue, like this constant, only one of the three. And recently, TypeScript has introduced this concept of string-based enums. So you can basically just assign a string to these constants. And then, of course, you can do it because you can just have, you can just switch the strings to these enum types, and then you can actually be sure that when you have this loop, that you're only putting in actually colors, so that this variable color is of type color. But you can even still console log it, like as if it was a string. So for these cases, I think it's a nice remedy where it's sort of caught up with what was possible in Flow before. Yeah, so that's sort of a bit more involved example of what type inference through control flow analysis means.
Yeah, and I mean, enums might look a bit redundant. You could just use constants, but then there's always someone who's comparing, who's not using a constant, and who's using the actual integers behind the constants or whatever. So enums just make that a little bit easier because you can compare to them against them directly. Another new feature, and this came with 2.5, I think, I'm not sure, is that now you can add the TSCheck annotation at the very top of any JavaScript file, and then this will be parsed. So if you use this, for instance, in VS Code, this will automatically be checked using the TypeScript checker, which means that you don't have to do any big changes to your code base. You don't have to rename the files. You don't have to add any types. And this will already help you figure out a lot of problems in your code. So if you're not sure if you want to use TypeScript or not, just add TSCheck to your files in an IDE that supports it. And then you'll get great results. Also, what it does is that now these little things that we tend to write every now and then in JS-doc is being parsed now by TypeScript, which means that finally they're actually being validated. So those things that we've always put there hoping that a person will actually use them, now we can actually validate them. So in this case, if you start typing, you will just notice that your IDE will start auto-completing everything because it can use the information that's there, even when you're not using TypeScript. So that's pretty amazing.
It's nice that a lot of people already are using this. So for example, we have them in some code. So we should start putting TypeScript on it.
Definitely. Okay, and there's a counterpart for that, which I'm not sure we should even show, but there is TSIgnore. If you're bothered by some of the things that TypeScript ignores, complains about, you can ignore this. I'm not too sure if that was a good thing, because now you will start to see those annotations pop throughout your code. It would probably be better to fix them. Yeah, fix them. Yeah, right. Not configure them at all.
Except for this single use case here, right? This is such an important use case. Everyone loves this.
I always do that.
Yeah, I always do that too. So much fun. Oh, sorry.
Okay.
Another nice thing about TypeScript is, of course, you have this language server, which works in the background. It's already part of TypeScript, so if you've installed it, then you already have it. And for example, it's what Visual Studio Code uses to validate your TypeScript or JavaScript even on the fly. Also, WebStorm does it. So basically, it provides an API for editors, so not every editor has to implement their own type checking and their own refactoring mechanisms. Yeah, so what it does, I already mentioned it, type checking, quick fixes, so you don't, if you're writing an editor, you don't have to do that yourself. Refactoring, so recently this has gotten a lot better. These extract function and extract method refactorings are now part of it. Rename symbol has been around for a while, I think. So that's pretty nice. So even if you're using Emacs, for example, there's a package or something for this.
Or use a proper text editor like Vim, then you can also have a package for this.
Yeah.
That's one of the things we can agree on.
So,
But yeah, so yeah, pretty much if you're using VS Code and you like how awesome VS Code is, then it's very likely that you're actually going to enjoy using TypeScript. So it's time to come out of the closet and just use TypeScript.
We don't work for Microsoft. Yeah, this is just a quick overview of how it works. Pretty simple. You have this server, so your editor might send, it just communicates via, it's just standard input. So it just puts, like you can, for example, make a Unix socket, and then you send these commands, like I just opened a file, it's like this file source /index.js, and now please give me the completions for line 73, offset 14, and then it answers, yeah, here, this is your response, and then the editor can take care of this. So pretty straightforward.
Yeah, so the one problem that we always have with JavaScript, which was terrible IDE support, is now finally being solved by this. All
right, let's talk a bit more about type systems. So a bit more, well, maybe a bit theoretical, but still quite superficial. What kind of TypeScript system is behind this? So one thing you always want to talk about when you talk about this is like you have structural and nominal typing. Well, these are sort of the two extremes that you can have. Basically, in TypeScript, types are structural, which means, in contrast to Flow, for example, which has nominal typing for classes. Basically, it's what everyone some people know it from other languages, or also how many people used to write JavaScript still write JavaScript. If you declare two types and they're compatible in terms of their structure, then you can assign them to each other. So if you have a class apple and a class fruit, even though apple doesn't inherit from fruit, you can still declare a variable pair of type fruit and assign it an apple because they have all the same fields, so it's fine, even though they're not the same type and they have different names and they don't inherit from each other.
So yeah, in Flow this would actually crash because nominal pretty much just means comparison by name instead of comparison by structure.
And some people know, well, you might know this as duck typing. So if it walks like a duck, then it is a duck, right?
Yeah.
So that's pretty straightforward, I guess. So another thing which is often debated in terms of type system are these notions of soundness and completeness, which quickly we want to just remind you what it is, what they mean, soundness and completeness. Basically, if you have a sound type system, what it means is that your type checker will catch all the errors that might possibly happen at runtime. So you will never have a program that's faulty that your compiler will not complain about. Basically, completeness means you only catch those errors that actually will with absolute certainty happen at runtime. So it's sort of a different notion. A nice analogy which I found in this blog post is not about types but about a jury. So imagine a jury. So a sound jury, that means that they will never set a guilty person free, while a complete jury means that they will never send an innocent person to jail. Well, of course, it's quite easy to just be complete because you can just always say, well, I'll never send anyone to jail. So if you have no type checking at all, you're already complete. But of course, if you want to, you of course want to have like sort of a nice trade-off, and you want to go towards soundness, and then it becomes more and more difficult to also be complete, of course.
Yeah, I had to put that in there. That just means that, like, maybe that's the wrong slide. I always want to put this in every talk. It just means that, like, with JavaScript, we have like a lot of. It's a very powerful language. You can do a lot of things that you cannot do easily with other languages, but that power comes with responsibility. And so you can look at it in a way that with TypeScript, the stricter the type system, of course, the harder it becomes to do crazy things. But maybe that's sometimes a good thing. So yeah, Spider-Man.
So one interesting aspect about soundness and completeness is in this example where it's about contravariance and covariance. I like this thing because I like to think of enemies and friends. So covariance is sort of like, these are my friends. Contravariance, these are my enemies. Sounds really weird now that I'm saying it in front of you. Sorry.
Yeah, we had to put terrible things in. Yeah, we couldn't agree on this.
Nice. So let me explain what that is and what this has to do with soundness, completeness. So covariance, that's like the way you would expect things. So for example, if you have a type apple and a type fruit, and apple extends fruit, then if you define a fruit, this fruit can also be an apple, right? So you can assign an apple which you just created, which is not very tasty but very red, you can assign that to a variable of type fruit. Also, if you have function types, then covariance is what you want to look at if you're comparing return types. So let's say you have this create fruit which takes which is of type that it can hold a function, like for example a callback, and this function always returns a fruit. And now we actually do define a function. It's called createApple, which creates an apple, and it's not very tasty but very, very red, this apple that we create. So now this createFruit variable can actually also create an apple. It's fine, because all we know is that this should return a fruit. Well, it does. It returns an apple, and an apple is a fruit. So this is the way you would expect. This is your friend. It's a covariant thing. So contravariance is sort of the opposite, and you have to take care of it if you look at parameters of function types. This is sort of not enough material.
I think yeah, that was sacrificed for the sound.
Okay. Okay, so let's look at this. Can you zoom it in again?
Yeah, here the left part is not really.
It's a similar example, but now we have two functions. Well, we have we have two functions. One is, or two variables. One is called rateFruit. The other one is called rateApple. So rateFruit, we don't define what it actually does, but we just say this is always a function that takes a fruit and outputs a number. Now, rateApple is a function, an actual function that takes an apple and returns the apple's redness. So that actually does return a number. So now, well, we think, well, like an apple is also a fruit, so let's just assign rateApple to rateFruit. But that's not a good idea. Yes, great. So because also TypeScript now finds this mistake since 2.6, if you turn on strict function types, as Michael just did.
Yep.
Did you do that? Yeah. So it actually complains about this, so that type apple, like this function type that takes an apple and outputs a number, is not assignable to this other function type which takes a fruit and outputs a number. And yeah, so it actually works the other way around. So here you have contravariance, and you can see what's wrong with it if you now try to call this rateFruit. So you know that rateFruit, you can put in an apple, you get a number, so you just call this with a new apple.
Could you open the frame in a new tab, maybe? Would that help?
That might help if let me see if I can share this. Text buffer too large to share. I'll show it again at the end of the talk if that's okay. That's easier for switching.
Yeah, actually this example would even work. So what you can't do is rateFruit with a new fruit, right? Because you know that rateFruit is now equal to rateApple, and rateApple relies on an apple to be in there. So if you just have a fruit, then you have no redness. So which one was mine again? No, this one. So this actually should fail, and it didn't used to fail because this is like how a lot of JavaScript was written. So the TypeScript people were always like, oh yeah, like we're not putting that in, we're sacrificing soundness in this case. We don't want to catch all the errors that might happen at runtime because a lot of code was written like this. But I think this is a really important example where you have to actually catch this error, and you can now, if you, with a compile time switch.
So yeah, those of you coming from a Java background, if you know, like, if you've been in huge software systems where there's a lot of inheritance, and then people start to implement methods and then just throw like not implemented or unsupported operation exceptions, it's because they didn't understand this and how inheritance is supposed to work.
Next.
Oh, still wrong focus. Yep.
Yeah, so this is the same example. So here you actually have this contravariant thing. Okay.
Yeah, so summing up, I think, I hope we could show you that using TypeScript now does not mean you completely have to change your code. You're already getting some of the benefits without changing a single line of code. I would encourage you, if you haven't tried it yet, to just npm install TypeScript and just add the type annotation and see what type of error messages you're getting. We've dug through a lot of blog posts about people who converted large code bases to TypeScript, and all of them have said that while of course it takes time to, if you're actually getting to the point where you introduce types in a large code base, but they found numerous bugs by doing that, and I think that's worth the effort.
Yeah, another thing which I think we talked about was that, so a lot of the things that we initially stumbled upon I stumbled upon when I started using TypeScript, and then I checked out what Flo was doing, was like, oh yeah, that would actually be better, but I still want this other feature of TypeScript. Well, things are being addressed slowly. For example, I really like the strict function types. I like the TSCheck annotation and these things. So there's actually nice progress.
So I think if you're more using more of a functional style, the benefit is going to be less than if you want to use a more object-oriented style. But if you're actually planning on doing object-oriented JavaScript, then TypeScript I think is a must. Mostly because you're getting like proper private fields, you're getting these nice helpful constructors. Yeah. And the documentation is great, so you don't need to buy a book. You just read the documentation, and there's anything that you... Or you buy this book, yeah.
TypeScript for babies.
TypeScript for babies, yeah.
That's part 4.
So yeah, do you have any questions?